So let's talk a moment about pure functions. When we're talking about functional programming, one of the key tenets of it is something called a pure function. And the idea here is that all incoming data is immutable. And one of the things that this is really important is that this means that the function body can't change data that's outside of its control. It just gets a copy of some data coming from the outside world and has to work on it and then produce a result of some sort. No side effects. This, goes along with that. It can't reach out to the data that came in. So if you passed in a mutable list of stuff, the function could obviously add things to that mutable list. If the data is immutable, so if you have an immutable list coming in, it can't modify it. But there's other side effects you could do. So maybe if there's some global variables you have access to, whether they're singletons, whether they're actually global variables inside of a Kotlin file, you're not modifying those. These types of things, if you handle, if all your data is immutable, if you have no side effects on it, it makes your function very, very predictable on how it's going to behave. It's only going to operate on this immutable data. It's only going to do something and perhaps return a result. Idempotent means if you have the same parameters coming in, you get the same results each time. So it's not depending on some kind of an external force. Time is one of the things that sometimes makes a function not idempotent. You may be returning a different result based on time. But if your function is only depending on the data coming in to produce the data coming out, that makes it a very predictable function and a very testable function. So when you write a unit test against that function, when I pass in certain inputs, I'm going to get certain outputs back. The more you can do functions like this, the better off you're going to be. Now, obviously, you can't have every function in the world be like this, or your program is really going to be pretty useless, unless all you're doing is saying, hey, enter your age, and I will tell you what day of the week you were born. Something like that, somebody passes in their age to the top level function, it does whatever it wants behind the scenes and comes back. It's possible that it's a completely pure functional code for that. But for the most part, we have databases we need to store stuff in. We have other external data, whether it's in a file or coming across a network or something. We have state that we care about, so that as things are going on, we want to update the state and kind of remember what the user was in the middle of doing things. So the more you can push that up the chain, and we call this hoisting, where any type of state you move as far up, as far close to the main of your application, or as far to the top of the application as you can. If you keep your state up there, your functions below can be a lot more pure. That's kind of the idea with pure functions. And the more you can strive for that, the easier it's going to be to do some testing on your code. And the more your tests can be isolatable. Another little thing, dependency injection. And I'm very, very fancy on dependency injection. There's some really good things to it I'll talk about. But my main issue with dependency injection is people tend to overuse it. And what ends up happening is it becomes very, very difficult to actually follow the flow of your program and figure out where data is actually coming from. But the main idea behind dependency injection is don't call me, I'll call you, otherwise known as the Hollywood principle. And the idea behind this is that instead of a function reaching out to get something, it only depends on data coming in. Instead of a class reaching out and grabbing data, it only depends on what is passed to it. Let me give you a little example of something like this. If we have a database application, we might have a class that I'll call the database. And the database class is the one that's going to do our CRUD operations. When you have an instance of this database, you need to create it somewhere. And what we've seen so far is we've done with a class, the view model, let's say. So far, we've created the database inside it. And the problem there is that if you create your actual database inside your view model, like we've done earlier on, you now have the one true database. There isn't a way to replace that database with something else for testing. Because when you're testing your view model, it would be really nice to say, I don't want to use the real database. I want to use a fake database, a mock database that's just going to tell me if the calls were made to it from the view model. We don't want to actually create the real database because then you need a real environment to host that database. When you're doing unit testing, you want to try to keep these really small and lean so they run really fast. And you don't want to spin up a whole emulator to do things. If you're actually working with a database, you either have to spin up an emulator or use some alternate database mechanism that stores it to the file system. And that's going to slow down your tests quite a bit. So instead, we want to pass the database in or provide a fetcher for the database. And there's a couple ways we can do this. The most basic way is to use some kind of injection. And I'm not talking a dependency injection framework. There are several frameworks out there. I'm just talking about the general concept. And the concept is you're passing the data in. And so what that means is if I had a class, the database, and he has some stuff inside of him, and then I have a class, the view model, I would take and pass in the database to it as a constructor parameter, for example. And this is called constructor injection. And the idea of the constructor injection is you just, any external dependencies that you need, any external objects that you need, you pass in via your constructor. Now we probably would have this be a property, something like that, so that we're going to have access to it inside the code. That's one approach. We can also do, instead of using the constructor, we can do property injection. And inside here, we might have a var DB, the database, so that somebody can explicitly set that. So again, we're not creating it, which is what we did before. Let me actually come up here and put that in here. Private, oops, val db equals the database, something like that. So the one true instance, or one true, I'll call it one true instance. And what this allows us to do is that when we're writing our tests for our view model, we can pass in whatever we want for that database. We could pass in the real database, we could pass in a mock database, we could pass in something else. And what we really want to do with a layer like a database to make things even easier is instead of directly using the database, we can take advantage of the repository pattern that I've mentioned. So if we ended up having a class, the repository, who ends up taking in the database, and then he has some functions in here, create equals db.create, something like that. Find maybe we have inside here, if in local db return else fetch from network, put in local db return. So you might have some logic that looks something like this in your repository object. This is one of the more common uses of a repository object is for caching. So you're using this local database to cache. And maybe we have something in here that is a REST API object. kind of like we did before. And then we use that some REST API object to do the fetching. So the repository itself doesn't create these things. He ends up getting them passed in. Sometimes this is easy to do, sometimes it's not easy to do. In the case of view models, there's a specific way that view models get created. There are some special factories you can set up to allow you to do this, but it's some extra work to do things. Another option, instead of getting the data passed in like this, is called a service locator. And the idea with a service locator is this is a third object, and it's usually a singleton that everybody can go to find the ground truth. So you might have something kind of like class the service locator, and he has inside of him a fun get database, which is going to return the database and whatever other objects. And then the other objects would do something kind of like, actually, I would say instead of this, it'd be object in Kotlin, meaning it's a singleton. So there's just one of them that everybody can go to. He can come in here and say val db, let's say private, equals the service locator dot get database, something like that. So now we're reaching out and letting somebody else provide it for us instead of us creating the object itself. The trick with this is that if we did things with dependency injection, the tests stay pretty simple. The test just says, when I want a repository, I create the database instance I want, then I create the repository passing that database instance in. That's pretty simple for some test code. And you can change whatever database you want pretty easily that way. With this approach, it's a little bit trickier because you need to change what the service locator is sending you out. And usually what people will do here is maybe instead of using that, we would just have var database, the database, and this would just be service locator.database. And when you do your tests, then inside here, we would say the service locator dot database equals whichever database we want to, let's say some mock database. And then create your view model who will fetch that for you. So doing something like this, that works, but you have to be a little careful here because when you set this, boom, now you've got that thing set for anybody else who's trying to fetch data afterwards. So you want to always make sure in a case like this that you're doing something kind of like a try finally. Where maybe we do something kind of like, let's say var, I will say val old db equals, and we'll just kind of hold on to that and then reset it after here. So this might be some standard code if you're using a service locator pattern to do your writing your tests, and then whatever test to run, something like that. The big difference here, let's go ahead and do the same kind of thing for the dependency injection one here, where we might say val view model is the view model some mock database. And then whatever tests you want to run, making your test a little simpler there. That said, sometimes you have objects like your view model that are tricky to mock up and get them to actually run the right way in the normal scenario, in the normal way you'd run them. With a view model, for example, in Android, your default for that is to have the view model have a 0 argument constructor or a one argument constructor if it's an Android view model, because you're going to get that Android context passed in. Otherwise, you have to set up a factory for it, which is a bit of work. It's not too bad. I haven't done it with the newest code. I've done it with some old code where it was pretty verbose to actually get the view model to start with. Then you pass in a view model factory that will actually be responsible for creating it and setting the dependencies. It's doable, but it's kind of ugly. There are some third-party libraries out there to do dependency injection, manage that. I'm going to go through some examples in a little bit, but the general idea is that you'll have something that you define a module. Most of them have some concept of modules. And the module is a mapping of types to the actual implementations. And sometimes this can actually require a good bit of code to set up. Then what you'd have is when you use something, you use annotations to indicate where the framework should inject things. Whoa, I can't even spell today. I was doing pretty well there for a little while. So that might end up looking something kind of like if I had a class, the view model, then inside here, I might have something like a var db, the database, with an @inject annotation in front of it. And then we would ask the framework to create the view model instance. And when he says, I'm creating this, he takes a look at the class and says, oh, I see some spots where I need to put other stuff in. And he would see here, oh, I'm injecting something of type database. I'm going to go and look at my modules. Get my indentation right there. I would look at my modules to see what I should actually be creating an instance of and pass it in. If you do this for just a few choice things like your database layer, your view model, maybe a couple other things, then it's not so bad. It's something that is pretty reasonable. I've seen people do this for like 30, 40 different types in their applications, and it gets really, really hard to debug. If there's any odd behavior going on and you're trying to figure out, well, what's actually happening, you get these stack traces that come out that are 3 miles long for when it's creating instances of things. So if you decide to use a dependency injection library, keep it fairly light. Try to use it only for a few key things that everybody needs access to, like the database, like the view model, stuff like that. That way, it's like you can manage that and have those passed around very easily and accessed very easily without actually causing you a lot of problems in debugging. So these are a few things to kind of keep in mind when you're designing your applications and designing your tests for them, trying to make things so that more testable. One of the things here, when I mentioned a mock database, one of the types of things you want to do when you're testing is you want to keep the tests shallow. And what I mean by that is if you have external dependencies, maybe it's hitting a real database, you don't want to go down several layers to run the real code and do real work. What you're really concerned when you're testing a function is, am I actually calling these other things? And then provide some kind of a dummy return value from them. And what that does for you is makes it so you're testing just the function you care about, as opposed to the function you care about plus all the things behind the scenes on it. And to do that, you can provide a mock implementation of interfaces or mock subclasses that you can use. And all these guys do is track which functions are called and dummy up some return values. so that you're not actually doing any real work behind the scenes. Because if I've got the view model, I'm trying to test the view model layer, I don't want it calling the database layer. I'm not interested in testing the database layer at that point. I'm just interested in testing my view model and to make sure that his logic is okay. I'm going to have separate tests for my database layer to make sure the database is okay. And then later on, you can have integration tests that do the whole gamut of things. But the integration tests are ones that are going to take longer, and you're usually going to want to run those on an actual emulator. Let's take a look. I just created this new project called Compose Test, and let's look at a couple things that are actually inside of here. We're going to take a look at underneath this app, the build.gradle for him. And you're going to notice here they have this test instrumentation runner. This is actually the JUnit class that's going to be running the Android tests. And what that's going to do is hook up to an emulator and run instrumented tests on there. When I say instrumented tests, I mean that the code that you're running, it takes your code, puts in some hooks inside the code so that we can get some feedback from the actual test that's running on the device. That's called an instrumented test. Anytime you're instrumenting code, it means you're adding in some little hooks to share information or give other ways to communicate with it. And so that's just going to be for running your tests on the little emulators. Down here, where we have these guys, this is where it gets a little interesting. Notice that we have several dependencies that are marked implementation. These are going to be used regardless of how you run the code. So whether you run it in a debug build, whether you run it in a release build, or whether you're running a test on it, that piece of code is always going to be there inside the application that's been built. When you say test implementation, this code is only going to be used during a test. When you say, and in this case, we're talking about a unit test. We're talking about one that doesn't run on an Android emulator. When you say Android test implementation, these are things that are going to be running on the emulator. So you're going to need different pieces of code to actually run that. Espresso is a test framework that they use for some of this. We're actually not going to be using Espresso. Espresso is mainly used for view tests. Some of the stuff we're doing with the Compose testing is going to be somewhat similar to Espresso. I find it a little easier. Espresso can be a little wordy, but you can use it for some things. It's something that for Compose, stick with the Compose tests. It's really easy, the framework that they've set up. So let me first of all go back and fix. So he's good, he's good, he's good. I want to fix this guy up here. We're going to replace him with a specific version. And there we go. Let's sync him up, make sure that's all okay. Now, when you create your project, it's actually going to create a couple test stubs for you that you can use as starting points. If we take a look under app source, you'll notice these two directories, Android test and test. Android test is where you're going to have your instrumented tests, and those are ones that are going to be run on an actual emulator. And test are the ones that are your unit tests. So these are going to be run just in a little Java environment. That's it. So it's not going to actually have to start up an emulator or anything like that. So let's look under here first. You'll see that it comes up with this example unit test. And if we open him up, this is a sample JUnit 4 unit test. And they're real simple to write. Basically what we're doing is defining a test class here, and any class that has a test annotation on functions is considered a test class. So they're giving you this little dummy addition is correct function here. And he's just going to say, is the expected value of 4 equal to the actual value of 2 plus 2, which I really hope comes up true. You'll notice these little markers here. These are markers that let you run this test. So you can run individual tests using the marker on the function itself, or you can run all tests for a class at this level. You can also run these tests from Gradle, and it's really useful if you have some really fast running unit tests to put those in your continuous build. If you have a Jenkins server, for example, to set up to run your builds every night, you can have as part of that build running your tests. And it's just a matter of saying Gradle W tests, and it'll build everything and run any of your tests for you. If you have a bunch of these, you can actually keep making sure that your code is behaving like you expect it to. Obviously, up front, you're not going to have time to write tests for every part of your application. But a good strategy, anytime you have a bug reported, the first thing you should do is write some test cases that demonstrate that bug. And you're going to write the test case in a way that it's reporting what you expect to really happen. So in this case, I'm expecting 2 + 2 to be 4. But maybe when you actually run it, 2 + 2 is 5 for some reason. The test will fail at that point. Your goal is, of course, to fix the software so that the test will pass. And then you leave that test in the baseline so that you can't let that problem sneak in again. So that's a pretty good strategy for starting to add in some tests over time. And then once in a while, as you're writing new code, write some tests down that check things. Now, don't write tests that are useless. Don't do things like, I'm going to test the getter and setter of every single one of my properties. Especially if you're doing Kotlin code and you don't have control of the getters or setters most of the time, unless you override them. But like in Java, a lot of people would spend time writing tests for all the getters and setters. And once in a while, you might catch a copy paste that way, but it's really, really rare. Because if you're using your code generation tools inside the IDE, it's going to do the right thing for you. You really want to focus on things that actually have some kind of business logic to them so you can do the test. So let's take a look and see how this thing runs. I'm just going to run this individual test by clicking on him. And we'll see down here our run view came up here. And we get our test results with a green check mark, meaning everything's fine. Let's change this to a 5 to see what would happen if we ran that and the results didn't match. And we'll see here they have little X's here. And if we click on it, it's going to say the expected value was 5, the actual was 4. So we know that there was a problem there. Now that either means that your test is wrong or your code is wrong. So you have to figure out which one's which there. Sometimes your test is wrong. Now, one thing I like to do with these in Kotlin, these function names, I don't find them super readable when you're looking at test results. So what you can do in Kotlin is take advantage of the fact that you can actually put spaces into function names if you use back quotes. So if I come in here, I can say back quote addition space is space correct back quote. And I only ever recommend you use these for tests. Never ever use this for a real function name. The thing with the back quotes is you can back quote anything. It could be a keyword, it could be anything you want. Quite often you'll see people do things like something like that, where they're reusing the when keyword as an actual variable. Most of the time when you see this, it's because they've converted the code from Java code. And in the Java code, they happen to have a variable called when. And when it got ported over to Kotlin, boom, we got a conflict between a keyword and an actual property name. And so they had to back quote it for you. So you'll see this come up sometimes. I don't recommend you do that. It's easy enough to time the thing happens. I don't know. It's easy enough to come up with a more descriptive name than just when. So I don't recommend you do that. For tests, though, I strongly recommend you name your tests using spaces. And it just makes it so much easier to read, because when I look at this, let's actually make that fail again. We'll see here, addition is correct. It's just so much more readable. And especially like if you look at the generated reports, when you run it from Gradle, it'll generate a HTML file with the test case names and all the reports. And this just reads so much more nicely for everybody, whether it's the testers who are getting these reports, whether it's the programmers, whether it's the program management, they can read this and it actually makes a lot more sense. I'm not going to go into super detail on how JUnit works. A couple things I want to mention. You can do in each function whatever setup you need to do. Inside tests, maybe you're going to do some setup, and you might have the same setup in every single test. So what you may want to do is set up a common piece of code that runs before every single test. So you can do something like a before. And you can call it setup or whatever you want to do. Like maybe you're creating your mock database or something at that point. And this will run before every single one of your tests. Now you can similarly do something after to clean up after each test. You can also do a before class, and this is going to be a overall setup. I don't know, whatever we want to call it. And this is something that runs once before anything else, any of the tests run. Sometimes that's useful. The thing you got to be careful of here is if you use it before class, for example, and you set up some common objects, that object is going to stay through all your tests, and there's no way to know which of your tests is running in which order. The tests are supposed to be all independent. So what could happen is a test could change the state in one of those objects, and you want to make sure that you reset that state every time, or call setup to create a brand new instance of those state along the way. So just a couple little things to note there. I'm not going to go into a whole lot of detail there. But what I'd like to do is kind of do a quick setup of a very, very simple database application here so we can kind of see how you might approach testing some of these things. Android room, let me get the dependencies that we need here. And I'm not going to bother with the room testing right now. So let's bring these guys in. So let's create a, oops, I want to put that into the build first. And then let's actually just create a movie class again here. And we can say entity. Not going to do anything fancy with this. We'll say var ID. Actually, let's make him a data class. We'll say var ID string equals UUID, random UUID to string, and then maybe just a title. So there's our nice little entity. Let's create a quick DAO. Let's do a real quick query here. Select star from movie. And this is going to be fun, get movies. And I'm going to say flow list movie, something like that. So that should asynchronously give us a movie there. And I should be able to change that back to an interface. There, that's better. Okay, so now we've got a real simple movie DAO there. Now, if we go with the repository approach here, what we can do is create a new class here that I'm going to call movie repository. And I'm going to have him take in a database. So I'm going to say val db is going to be, oh, I didn't create a database class yet. So let's come in here and say database, movie database. And I'll say version equals 1, entities equals movie class, something like that. And make him be abstract. Oops. And then fun movie DAO. Movie DAO. Abstract. There we go. So now we have a simple database set up there. Let's come to our repository. It's going to be a movie database coming in there. And we could have just a way of passing that straight on through, basically. So I'm going to say fun get movies equals db.moviedao.getMovies. Something kind of like that. So at its lightest, you could have a repository that's just a pass-through for all these functions. This gives you a place that you can mock out. So now that we've done this, it's very easy to create a subclass of this that mocks it for us. And we can do that using a mocking framework that I'll show you a little bit later. So we got that. Let's set up our view model. So say movie view model. And he's just going to be view model. And we'll pass into him a val repository, movie repository. And then we can also forward those same setup there. So let's see, how did I want to do that? Repository, get movies. And that way when it changes, we can just get that passed through. Don't know if we'll be needing that as a val. I'm just going to leave it as a val for now. Let's make it private. There we go. So this might be what our view model looks like there. We might have some other functionality inside here, like let's say create movie with a title. Something kind of like that, which just gives us a simple function that returns a movie there. We could test that function and so on. So now we have 3 layers here so far. We have our database layer, we have a repository in front of it, we have our view model on top of that. Then we could create a user interface. So we go to our main activity here, and let's just say movies. We'll deal with what's passing in him in a minute. And we can say movies, which is a list of whatever types of movies we want here. And one thing that might be interesting here to do to help our test is to isolate the layer where we talk to the view model so that we can have a composable function that takes a view model and is responsible for doing all the, let me grab the pieces I need and pass them down to the lower functions like this guy. What that lets us do is we can mock out the view model and just call that composable function to isolate the checks to see, are we handling the pulling the data out of the view model appropriately. So if I make a copy of him, and instead of having that, I have my view model passed in. Then inside here, we're going to pull out, do that collection on it. So I can say val movies by remember mutable state of, actually no, view model. Oh, was it equal or by? Collect that state, right? With an initial of empty list. And then let's just have it print up text for each of these guys. So I'm going to say movies for each. Oh, I need to put in my, hopefully at some point they'll set up some support to automatically put in this get value. So we don't have to keep putting that in manually. Okay, so then in here, movies for each, I'm just going to put up text where text is it.title, something kind of like that. And I'm just going to do that for now just to print that up on the screen. Anything else I'll do there? No, that's probably good. Oh, I'm sorry. This goes down here. And then we're just turning this around and calling movies, passing in movies. So this layer here is just responsible for interrogating, working with the view model. Everything below it shouldn't even know the view model exists. That way we can isolate our tests for our view model versus our tests for just the composable functions by themselves. Okay, so then this guy here, let's just put in a little thing to test up here while we're developing. So I'm going to say movies, list of movie, we'll say Romancing the Stone, and movie, what's another 80s movie? Yeah. Indiana Jones and the I Don't Wanna. Okay, so something like that. This preview, keep in mind, he actually can be very, very useful. I'm going to comment him out for a moment. So when we have him, we can go to the split view over here. If you try hitting this button here, that's going to try to run the preview on an actual emulator or device. If you open this guy up and then hit the little build button here, it should update the preview after it builds everything. Hopefully we'll see two things, Romancing the Stone and Indiana Jones, printed out there. So didn't put a column in there. That would help. Oh, actually, the column should be up here. That would make more sense. Let's try that again. Might need to actually say modifier fill max width. Let's see if that'll help. Okay, what did I do wrong here? The text is title, movies for each. So it looks like it's got two texts in there, or at least one text. I think that's two. Text is at title, modifier is fill max. It's the column. That looks like that should be okay. Let's do a text. Let's just do that to see if it shows up that. So we're getting the title and then we're getting two down here.
Can you scroll to the right? I think you have a scroll there. No, you're on your preview.
Oh, in the preview?
Yeah. It's probably in the middle. Nope.
Huh. That's interesting. So I got my list of movies coming in, the movie list of movies, fill the max width, text movies is good. So I really don't need to do a fill max width on these. I'm actually setting the ID, but I'm not setting the title. Ta-da! There we go, that's better. So now we got our little simple interface set up there. Okay, so the little hint that it gave with the ID actually came in helpful down there. So now we've got application set up. Let's think about writing some little tests for this. So the first thing we want to try to do is, I'm not going to test the database because that needs to be run on the actual emulator. Let's test the repository layer. So what we're going to want to do is pass in a dummy database for this. And we just want to see, is it actually getting called? We want to mock up that database. So we can either explicitly create a dummy database, a subclass of the database, or we can use a mocking library for it. Let's do an explicit subclass just so you can kind of see what's going on behind the scenes here. To do that, we first of all have to make this class open so we can make a subclass of it. With the mocking libraries, you don't have to do that. It handles that behind the scenes. But in here, we can then create a class mock movie repository, which is going to be a subclass of movie repository, passing in a mock database of some sort. So we're going to need to have I think we can do that because the database is already an abstract class. So we're going to have a class, or I could set that to null, which way do I want to go about it? I'm going to just, for this example I'm talking about here, because the mock will do something like this, I'm going to set that to null. And then that function is going to be kind of like that. I need to make the function open as well. So for our mock movie repository, we're going to override that get movies function and just return some dummy flow. So I can say equals flow, emit. It's movies, right? So movie, get smart, and Die Hard. Why not? And is, oops. Or empty list. There we go. So what we've got in here, we've overridden this guy to spit out some data. So this is one type of thing you can do with a mock, is explicitly say what the return value is when something's actually going to be accessed. Now, if we had a function in here, open fun save movie, that took a movie, and let's say the database had something in it to update it. I'm just going to put a little comment to represent that. We could down here do a save movie and do whatever we want. One of the things that we often do with a mock is just keep track of whether something was called or not. So we could put in a, I'm just going to make it public for now, because this isn't really how we're going to do it anyway. So we'll say get movies called and save movie called. And then we just do inside here, save movie called equals true. And get movies called equals true as well. This will allow somebody on the outside to actually check to see, was something called? So now what I can do to test this, actually I wanted to mock the database, didn't I? I did it the wrong way. Well, if I'm testing the view model, I'm going to mock out the repository, but I wanted to mock out the database, so I actually went the wrong way on that. Let's try creating that mock database. It's going to be a movie database, and implement the members. Let's have these do nothing, that does nothing, that does nothing, and so on. And then for the movie DAO, we need to mock the movie DAO. And he has the get movies. And so this is where I wanted to do what I just did up there. Oops. And we can do these up here. Let's go ahead and add in that save. Something like that. And what is he not happy about there? Oh, flow listed movies. Oh, yes. And one more. There. Okay, so that's better there. And is he missing something else? Save movie. And so the save movie is just going to say save movie called equals true. That's better. Comment out the mock movie repository for the moment. I'm just going to delete him because we're not going to do things that way in a minute. And let's see, so this guy here, this should just return mock movie DAO. So now I should be able to test my repository by passing in this mock DAO and then just see what the repository did. You know, I can get some data back. I can see if things actually got called. So when we write our test, I'm going to come down to example unit test. let's do an @test. And we'll say fun test repository. And so then inside here, we can actually create our repository. So we're going to pass in a mock database to him, just kind of like that. And so now we're going to use this as though we were using the repository for real. So I can say repository.getMovies. That's going to give us a flow. And we want to see that the repository is passing the call through correctly. The mock database should return us a list of things. So I should be able to say run blocking, and run blocking should only be used in tests. It gives you a way to hit your suspend functions. So we can say getMovies is returning a flow, right? Oh, list a movie. That's why he's not happy. So movie repository, flow list movie. Oh, that should be a flow there. Empty flow. Now I think that'll be happy. Let's go back to the test there. There we go. And so now we can do a collect on him and check to see what's going on. Now with the, when you're dealing with flows, there's actually a helper library called Turbine. Makes things a little bit easier to deal with. Kotlin Turbine. So you'll end up doing something like this, where instead of saying collect, you'll say test, and then you can just go ahead and call wait item on each of these to do your checks. So let's pull him in. Come down to here. Sync him. And oops, we're going to go to our test. Where was the test? There we go. And I'm going to say, instead of collect, I'm going to say test. And what is he unhappy about? Oh, it's experimental. So we're going to add the experimental thingy on there. And then in here, I can actually do assert equals whatever our expected stuff is. So I could say list of movie. Let's copy him from wherever he was. And come back over here. One more paren. So that's our expected value. And then we can say await item. And it should compare it. Now with flows, depending on the type of flow, if the flow is constantly producing things in the background, like this one actually is, it's considered what's called a hot flow. It's something that is going to keep sending data regardless if anybody's listening. So this guy is saying that I no longer need to use this, so it actually cancels the coroutine, and then the flow is not going to be sending anything new to us. So we're just going to check that one item. If you had multiple things you wanted to check, you could actually put those different steps inside there for checking them. And we might see those a little bit later. So this is actually going to check to see, did I get what I expected out of that from the repository? And the other thing I want to do is check to see, was the function called? So I can say assert equals expected. Actually, I'm going to say assert true. And then the actual check I'm going to have here. So repository dot get movies called. Wasn't that what I had it? Oh, I didn't put I need to break the database out there so I can actually access it. That would help. Oh, is the DAO that I wanted to do that for. What is he complaining about there? Oh, he's an interface. So I actually am going to need to pass the DAO in here so I can actually get to it. So DAO, movie DAO. And then I can just have that be returned. So now back in my test, what's unhappy here? Oh, well, shoot, he's going to need these things. I don't want to do this. Oh, this is a rabbit hole. Well, it's going to be okay because the mock is going to take care of this for us later on. Is it going to allow me to use? No, it's not going to make him questionable. He has to be returned. So let's see. This one is going to be equals null. This is where sometimes testing can be a bit of a pain because sometimes you get these rabbit holes where you have to return an object that has other mocks inside of it. It can be lots of fun. And this is this one is probably going to be nasty. Let's see how bad that comes up. Okay, I'm definitely not doing that. Is there any way I can do this? So create open helper. Is there a subclass of that I can just create an instance of? I can probably just return that one. Unless that guy is, no. So that should be okay. Let's try that. Of course. So let's go back up to his superclass. And then we'll look at the subclasses again. Is there anything here that I can do this with? No, he's package protected. Well, this one is not going to work. So in this, what this is telling me is that we can't really mock out these databases very easily. Let me check something here real quick. Mock room database. Yeah, they're just saying that do it at the that's where that room testing library comes in that I didn't look at. See what he says there, in-memory database builder. Oh, Well, that sounds like that's a easy enough way to do that. So we can actually just use the in-memory database builder, and then that'll work in a unit test. Let's do that. Rather than doing the mock on him, I'm going to show you the mock on the repository when we move up to that level. But we won't need the database for that. And I can get rid of the mock movie DAO. And we'll get all that stuff out there. Okay, so let's try this again. Take 42. So we're going to come into our unit test again here. And instead of doing that, I'm going to say room in-memory database builder. And, oh, we need a context. And why is that not showing up? Because Android Studio, I'm sure. I think that's what makes this guy available here. Okay, so what I'm going to do for the moment, I'm going to see if I can whip this up during the break, get this to work because it's just about break time. Then we can get the database one out of the way, which is really just testing the repository using a dummy database. Then we'll move up a level to the view model and see how we can actually mock out the repository there.